Theorem 1.26 Extreme Value Theorem. If f is continuous on the closed interval ab, then f of x achieves its maximum value and minimum value in the closed interval ab. Consider this function f of x is equal to sine of e to the x. It is a composition of two continuous functions. E to the x is continuous, sine of x is continuous. Therefore, their composition is continuous. So let us pay attention to the closed interval AB. A is equal to 0 and B is equal to pi over 2. What the theorem of the extreme value theorem is telling us is, if your function is continuous in the closed interval AB, you are sure to find its maximum value there. It will have a maximum value there. It will have a minimum value in that closed interval. And we will find the maximum value of our function at point A. It is equal to 1. And we will find in point B the minimum value of our function, which is negative 1. Consider this function f of x is equal to 1 plus x squared minus x cubed. This is a polynomial function. It is continuous in the entire set of real numbers. But for now, let us pay attention to the closed interval AB. A is equal to 0 and B is equal to 1.5. Again, the theorem is telling us that if f is continuous in a closed interval, your function is sure to show a maximum value there. It is also sure to have a minimum value in that closed interval. And we will find the maximum value of our function at point A. It is approximately equal to 1.10. So you will look at the y-coordinate of that point to estimate the maximum value of your function. And the minimum value is, of course, 0. Now, our concern when we are studying the maximum values and minimum values is not only about what is the maximum or what is the minimum. We shall also be concerned with what values of x, or where will you find the maximum value and minimum value. What values of x will give you the maximum and what values of x will give you the minimum. For our function f of x is equal to sine of e to the x, pi over 8 will give us the maximum value of our function in the closed interval ab. And pi over 2 will give us the minimum value of our function in the closed interval ab. For the function f of x is equal to 1 plus x squared minus x cubed, it is approximately 0.6. That will give us the maximum value of our function in the interval ab. And it is 1.5 that will give us the minimum value of our function in this interval. Absolute maximum versus relative maximum. Let f of x be a continuous function in the closed interval ab. F of z is the absolute maximum value of the function in the interval, closed interval ab, if f of z is greater than or equal to f of x for all x or for all x's in the closed interval ab. On the other hand, f of z is the relative maximum value of the function if there is an open interval in ab in which f of z is maximum in that open interval. By way of analogy, this is how I want to explain to you or to illustrate to you the similarity and difference between absolute maximum and relative maximum. In the world, we have the strongest man. He is this guy. He is the world's strongest man for 2020. His name is Alexei Novikov. In the Philippines, we have the Philippines' strongest man. He is Ray Jefferson Kerubi. Oleksii is the absolute maximum. He is the global maximum. He is the world's strongest man. But Ray is the relative maximum. He is the local maximum. He is the Philippines' strongest man. So in a small region in the world, that's why you call it relative, Ray is the maximum. But Oleksii is the absolute maximum in the world. He is the world's strongest man. Absolute minimum versus relative minimum. Let f of x be a continuous function in the closed interval AB. F of c is called the absolute minimum value of the function in AB if f of c is less than or equal to f of x for all x's in the closed interval AB. And f of c is called the relative minimum value of the function if there is an open interval in AB in which f of c is the minimum or the minimum value of that function in that open interval. Let us pay attention to this function, a continuous function, and let us consider the closed interval negative 1.5 to 1. Can you point to me where you will find the absolute maximum value of your function and the minimum value of your function in this closed interval? So it's going to be this. This point will give you the absolute maximum value of your function. And it is not just the point, it is the y-coordinate of that point. And it is approximately equal to 4.5. The minimum value of your function will be found at this point. When x is 1, f of 1 will give you the minimum value of your function in this closed interval. It is the absolute minimum value of your function, and it is equal to 0. Can you point to me where you will find a relative maximum and a relative minimum? This point will give you a relative maximum, and that relative maximum value is 1. Why do you call it relative? Because there is an open interval inside our larger interval negative 1.5 to 1 where you will find a point. Okay, approximately, this could be something like 0.8, where f of that c, okay, let's call that c, will give you a relative maximum. How about the relative minimum? Well, you will find it at this point, because there is an open interval inside the larger interval negative 1.5 to 1, where we will find a point c, such that f of c will give you a minimum value in that interval. And so our relative minimum value is approximately equal to 0.9. I will give these points names A, B, C, and D. Let us pay attention to our terminologies. Points A and B are called absolute extreme points because it is at those points where you will find the absolute maximum value or absolute minimum value of your function in the interval. Points C and D are relative extreme points because those points will give us a relative maximum value or a relative minimum value. Absolute extreme points are also called global extreme points. Relative extreme points are also called local extreme points.